Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, refreshed and inspired. And if my videos are important to your studies, also please don't forget to subscribe. By the force method, for the frame shown below, determine all support reactions. E is constant. So this is the only frame that I'm going to present and solve by the first method, because we know that the first method is long. The solution would be long if the degree of indeterminacy is greater than 1. But for frames with degree of indeterminacy greater than 1, I will present the solution by the energy method, because the the method of least work, because it is more direct and shorter in solution. So we will have more frames applying the method of least work in the succeeding examples. So here is the frame. This is statically indeterminate to the first degree, so there's only one redundant, and I select the vertical component of the reaction at A as the redundant force. So I remove the capacity of A. This is a pin to resist vertical reaction. That's why I changed it to ruler. So we will call the reaction here as EH. And let's apply P. Then so that we can compute the vertical displacement at A, or deflection at A. So we sum up moment about D to express EH in terms of P. So EH times 4, this is 4. Then equals P times 8 plus 18 times 6 times 5. So 8 times 4 equals 18 times 6 times 5 plus P times 8. So therefore EH is 135 plus 2P. So this is also 135 plus 2P if you sum up forces horizontal. Then the vertical reaction here is 18 times 6 plus P upward, so 108 plus P. Not already presented because that is statics. So let's section the members. So we have section X, then from there we proceed to this section X, then another X, then another X. There are 4 segments. But in this section, since there is constant for EH, so there is moment here. Remember, the moment of inertia is 2. So EI delta A vertical equals integral of moment at this section, which is AH 135 plus 2P times X. Then 135 plus 2P times X. P has no moment. Then the partial derivative of this moment equation with respect to P is 2x dx, then divided by 2 because the moment of inertia is 2I. Then we proceed to this section here. That's also positive. Here clockwise positive, here counterclockwise positive. So plus integral 0 to 5 of quantity 135 plus 2P times X. The derivative is 2x dx over 1, so I'm not showing over 1 anymore. The moment of inertia is just 1. Then for the next section, we have plus integral 0 to 2 of 108 plus P times X plus quantity 135 plus 2P times 5, the moment at that section. 5 is the moment arm. The partial derivative of this moment equation with respect to P is X, then 2 times 5, P is 10, so plus 10 dx. And finally, in this section, plus integral 0 to 6 of quantity 108 plus P times 2 plus x, then plus 135 plus 2p times 5 minus 18 times x over 2, so minus 9x squared. The derivative of this equation is 2 plus x, which is that. Then 2p times 5 is 10p, so the derivative is 10, so plus 10 x dx. So that's it. Then take note that we set p equals 0. It was just invented. Then evaluate the integral. The value of the first here integral is 32805. Here, after setting p 0, so integral of 135x times 2x dx, the value is 11 to 50. Here, after setting p 0, integral of 108x plus 135 times 5 close times x plus 10. The integral is 17 to 98. Here, after setting p0, the integral using your calculator is 100,602. So EI delta EV is the sum of these yellow values, and that is equal to 161955 over EI downward. Next, for the second part, P is 1 to solve for the vertical displacement at A due to the unit displacement, and let's just assume downward displacement, and we remove the loads, and that value is FAA. So we have 1 here, which is P is 1. So if we solve for this horizontal reaction times 4 equals P times 8, so 8 over 4, so this is 2P. So summation forces horizontal, that is also 2P. And summation forces vertical, that should also be P equals 1. And horizontal reaction at D would be 2P rightward. So same sectioning as before, but this time the value of P is 1. Take note. X, then X, then X. 4 segments. So EI FAA equals integral 0 to 9 of 2P times X times derivative 2x dx, then divide by 2 because the moment of inertia is 2, plus integral 0 to 5 2p times x times 2x dx derivative. Then here integral of p times x plus 2p times 5, 2p times 5 plus p times x. Derivative is 10 plus x dx. Then finally in this section, integral of 0 to the 6 of 2p plus 5, 2p times 5, then plus p times 2 plus x. The differential of this moment equation is 10 plus 2 plus x, 10 plus 2 plus x, or 12 plus x dx, 0 to 6. So integrating, then prior to integration, we set p equals 1. The value of the first integral is 486. So here, p is 1, integral of 2x, so 4x squared, 0 to 5, is 500 over 3. Here, set p equals 1, the value of the integral is 728 over 3. Here, set p equals 1, the value of the integral is 1368. Therefore, EI FAA is the sum of these yellow values. FAA therefore is 6790 over 3 EI. Then compatibility equation, FAA times vertical reaction at A plus delta AV equals 0. So FAA, vertical reaction at A plus delta AV equals 0. So solving for A vertical, substituting 6790 over 3EI AV plus 161955 over EI equals 0. Cancel out EI. So AV is negative and we assume that it is downward, therefore AV is upward. AV is negative 71.556. It opposes this direction, therefore AV is 71.556 upward. Having found AV, we can now compute the reaction components of the rest. So let's apply 71.556. Let's call this the A horizontal, and here D horizontal and D vertical. So summation moment here equals 0. H times 4 plus 18 times 6 times 5 equals 71.556 times 8. So AH is equal to 8.112 kilonewton meter, and it is rightward. So it is also equal to EH is also equal to 135 plus 2P. If you substitute P equals negative 71.556 here, it will give us value EH here negative 8.112, because it is negative, so it means it's rightward if you substitute it here. Then summation forces horizontal, so AH equals DH, so DH is 8.112 leftward, and summation moment about A, or summation forces vertical vis-a-vis summation moment about A to, let's have moment equation, vis-a-vis times 8 plus DH, which is 8.112 times 4, then equals 18 times 6 times 3. So D vertical is 36.444 kilonewtons upward. So that if we check 71.556 plus 36.444 minus 18 times 6, it should be 0. So that's it for this problem.